Welcome back to the transformations of quadratic relations. Again, this is the last transformation we will investigate, and this time we have decided to subtract a number from the x and then square the x, right? So in other words, you can look at it as subtracting a number from the x inside the brackets. All right, so let's get started in here. Again, we're going to use a table of values. We could have used technology or Desmos very easily, but the problem is that we won't see what exactly happened and what made the parabola go where it will go actually. So here we go again. When x equals 0, then y will be equal to 0 minus 3 squared. So that's negative 3 squared, or 9. When x equals 1 minus 3 squared, that would be equal to negative 2 squared, or 4. And then x2 minus 3 squared, so that negative 1 squared, 1. 3 minus 3 squared, that's 0. And then 4 minus 3 squared, that's 1. 5 minus 3 squared, that's 4. And 6 minus 3 squared is 9. Okay, so we are going to use the ordered pairs now to draw the graph, and we are starting here from 0, and then we go 1, 2, 3, 4, 5, 6, and the y values will be, so I'm just going to plot here the points that I see more often here on the y column. So when x equals 0, y was 9. At x equals 1, y was 4. At x equals 2, y was 1. At 3, 0. And then the same pattern repeats. And I'm going to draw the graph. And there goes the parabola for the equation y equals x minus 3 squared. So what did just happen in here? Well, again, recall where the normal or the basic parabola would have been. So 0, 0, and then we go 1, 3, 5, right? Right here. So this would be the basic parabola, the blue one, and we see that subtracting a number from x and then squaring it made the parabola move towards the right, but in the horizontal direction. It hasn't moved vertically, just horizontally. So the vertex this time will be at x equals positive 3, y is 0. So that's the vertex. The direction of opening has not changed, so it still opens up. And the step pattern, again, hasn't changed, so we move over 1, up 1, over 1, up 3, and up 5. So we're going to write the 1, 3, 5 regular pattern. So we just subtracted the number, and we saw that the parabola moved as many units as this number. So what's going to happen if we added a number? So your guesstimation would be probably, again, moving in the horizontal direction because we are adding something to x. X is a horizontal coordinate, and then squaring it. But because we're adding this time, we're doing the opposite of what we did in the previous example where we subtracted. So maybe it's going to move to the left, but maybe we're wrong. So let's check and see. So I'm going to go with orange this time. Again, at x equals, I've chosen the values of x. And don't ask me why I chose these values. You will see later. So x equals negative 7. Negative 7 plus 4 is 9. Negative 6 plus 4 squared. Negative 5 plus 4 squared. Negative 4 plus 4. Negative 3 plus 4. Negative 2 plus 4. And negative 1 plus 4 squared. Okay? So here we get 4, 1, 0, 1, 4, 9. So let's plot all these points. So we have to go as far as negative 7, 2, 3, 4, 5, 6, 7 negatives. And for the y values, we don't have to go too high as 9. And at negative 7, we're going to say y was 9. At negative 6, y was 4. At negative 5, 1. Negative 4, 0. Okay, so I would say that mystery solved now again. And it does seem that we were right. So the parabola, compared to the basic parabola, right? 1, 2, 3, 4, 5. Has again impressed us with a new translation, so that would be a horizontal translation. Okay, so we're going to say that the vertex this time has moved at negative 4, 0. That's right here. The direction of opening has not changed, so it's still opening up. The step pattern hasn't changed, it's still 1, 3, 5. So translating a parabola either vertically or horizontally does not change the direction of opening. Okay, the only number that changed the direction of opening was the number we multiplied x squared by. Okay, so what effect has a number added or subtracted to x in brackets in the equation of the basic parabola? And here's where things get more complicated, actually, the interpretation of it. And I'm going to give you the interpretation of the book, which I think it's a very good one. So when we have a parabola in the form y equals x minus some number squared, this is what's going to happen. Please try to remember this. So if h is positive, which means that, for example, we're going to say, if h is, what did we have there? Positive 3. Then the equation will become y equals x. Now this minus is still here, minus positive 3. We're going to say that the horizontal translation, and for short, we're going to write horizontal translation HT. At least that's how I like to, what I like to use. We're going to say the horizontal translation will be to the right. Okay? And in this case, 3 units to the right in this example. But in general, we're going to say if h is positive, then the parabola will move h units to the right. Now, if h is a negative number, and as an example, I would take h equals negative 4, then the equation of the parabola will be y equals x. And remember that this negative sign is right here, the blue negative sign, and I'm going to keep that in there for now. And h is a negative 4. So we're going to subtract negative 4 in here, squared. Now, you see this negative that is in the equation? And the negative from h, that's what makes this positive. And we're going to say this is the same as if saying y equals x plus 4 squared. Now when this happens, so when we add a number inside the x in brackets, the horizontal translation would be in the left direction. Okay, so that will make the parabola move to the left. So you are going to go to the left, okay? Now, this is kind of weird when we think about, when we learn it for the first time. So if we're told, hey, this is a parabola, y equals x plus 5 squared, in what direction would it move? So whenever we see a positive, we think, hey, it's moving in the positive direction, right? So maybe it's moving 5 to the right. But that's not what happens actually. So when you see a plus, the opposite happens. The direction of translation is in the negatives. And when you see a minus actually, so y equals, let's say if you had x minus 9 and then squared, then the parabola would move to the right, even though you see the minus. Okay? So how do you remember this? I remember when I was a student, I struggled to kind of make this connection. So I thought, it makes more sense when I see positives to move things to the right, but it's actually to the left. So I remembered it this way. What makes no much sense to me, that's the opposite. That's what happens. Okay, so create your own ways. That's what I'm trying to say. Be creative and create your own ways to memorize things, but most importantly, try to understand them. Okay, so in the next investigation, we have the stretches of the parabola. So y equals 2x squared. We already saw them in the previous lesson. So what we are going to do is not to use the chart, but simply draw the parabola right away because we already gone over it. And when we have y equals 2x squared, the vertex will still be at 0, 0. That didn't change, if you remember from the previous lesson. The parabola opened up, and the step pattern, though, did change. So the basic step pattern 1, 3, 5 was multiplied by this coefficient right here. The coefficient right here. So it was multiplied by number 2. And that changed the step pattern to become 2 times 1, 2, 2 times 3, 6, and 2 times 5, 10. So if we have to draw y equals 2x squared, that's how we do it nowadays. Now, because I say nowadays because you already learned how to draw this by using the table of values, right? And now that we have the tools, we draw it a bit differently. So 1 square is 1 unit, so we start at 0, 0, the vertex, and then we move over 1 up 2. Over 1 up 6, so 1, 2, 3, 4, 5, 6. We don't have more room to go higher, so the same thing on the other side of the axis, and there goes the parabola all stretched. Now in this case, we say that the parabola has the vertex right here at 0, 0, and the vertex will mark the lowest point on the parabola. In this case, then we're going to say that the vertex marks the minimum point on the parabola. And we're going to talk into more details about it in the upcoming lessons when we solve word problems. Now, in the next investigation, something similar happens. Now, we have a coefficient again before x squared. And as we mentioned in lesson number 1, that will change the step pattern of the parabola. So we're still going to have the vertex at 0, 0. The opening, we have to be very careful. The opening this time will change. And that's the only thing that changes the opening of the parabola, this coefficient being negative. So when this is negative, then we say that the parabola will open down instead. And the step pattern, as always, will be -3 multiplying the regular step pattern 1, 3, 5. And that will take the step pattern to become -3, -9, and -15. So let's graph it. 0, 0 will be the vertex. You move over 1, down 3. Over 1, down 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We don't have a room to go one more, but you see that the parabola here, it is opening down, and it is skinnier or taller, whatever we want to call it. I would like to call it taller, and I prefer taller. And we are going to say that in this case, the parabola opens down, and the vertex right here marks the highest point on the parabola. And when the vertex marks the highest point on the parabola, we call it that it marks the maximum point on the parabola. All right? And what is the effect when the positive or the negative number is multiplied to the equation of the basic parabola? We're going to write this now. Y equals, if you multiply parabola by some number, we call that number A, by the way. I'm going to say that if A is positive, the parabola will open up. And when the parabola opens up, we're going to say it will have the vertex at the minimum. So vertex marks the minimum point. And when A is negative, the parabola will open down. And the vertex will mark the maximum or the highest point on the parabola. And obviously, in both cases, positive or negative, the step pattern will also change. And the step pattern will become 1A, 3A, and then 5A. Okay? That's it for today, and I've assigned some independent practice for you. And I will do only one example. And let me try to find the more difficult example here, maybe example number 2. So I'm going to graph with you example 2, and you graph the rest on your own. Remember, when you graph a parabola, you always start from the vertex. Now, normally the vertex of the parabola is at 0, 0. That's the basic parabola. Now, if the basic parabola moves, the vertex moves as well, along with the parabola. And because the vertex is at 0, 0, it is very easy to see the translations by looking at the vertex, and then vice versa. So the translations will tell us the vertex, and the vertex will tell us the translations. Now, what are the translations we learned or observed? Now, we know that when we added this number at the very end of the equation, outside the brackets, that moved the parabola up or down. So -1 will mark the vertical translation. I'm going to try to make this, to highlight it better. Okay? So this will be, or will mark the vertical translation. So if the vertical translation is 1 down, that means that the vertex has gone from 0, 1 down, so at y equals -1. The next thing we want to look at is this number inside the brackets, which is +3. Remember how we said when we add the number to x inside the brackets, the parabola will move left or right? It will move to the left. So we'll say that this will be the horizontal translation of 3 to the left. So if the vertex has the x coordinate 0, then it will move 3 units to the left. So it must become -3. Okay? And then we're going to say that that would be the new vertex. All right? So once we identify where the vertex is, then we're going to plot it. X -3, y -1. So it's right here. And from the vertex, we have to apply the step pattern. Remember what helps us determine the step pattern. The step pattern is this number in here, the one that multiplies the exponential term, in this case, the exponential binomial. So we're going to say, well, then that means that the step pattern has changed from 1, 3, 5 to -1, -3, and then -5. So we're going to go over 1, down 1, over 1, down 3, over 1, down 5, which I don't have enough room for. So I'm just going to be happy with drawing this much of a parabola here. So again, remember that for parabola, all we need is a vertex and a step pattern. Okay? In a similar way, you have to identify the vertex and the step pattern for the rest of the examples. And I hope this made